Hello guys, in this video we are going to discuss the solution of the problem minimum cost of ropes. So let us look at the problem statement. The problem statement says given an array ARR containing the length of different ropes, we need to connect these ropes to form one rope. The cost to connect two ropes is equal to sum of their lengths. The task is to connect the ropes with minimum cost. So for instance, if this is the array which is given to us, then the minimum cost is 29, and the way we will be able to connect these ropes is first we are going to connect a rope of length 2 and 3. So the length we will get is 5. Then we are going to connect the length of 4 and 5, and then the length we will obtain is 9, and then eventually we will connect 9 and 6, and then the length we will get is 15. So in total the total cost will be 5 plus 9 plus 15, which is equals to 29. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example. So let us say this is the array which is given to us. The idea behind solving this problem is to use minimum heap. So what we are going to do is we are going to arrange this array in the form of minimum heap. So let us do that. So if you arrange this array in the form of minimum heap, then the heap will look something like this. And then all we have to do is we have to extract two minimums. And once we have extracted two minimum, so let me write it down over here. Extract two min elements of heap, then add these two elements, and then eventually we have to push it onto the heap. So let us do that. So the first two minimum elements over here is 2 and 3. So let's say 2 and 3 is something which we have taken out. So this is equals to 2 plus 3 and 5. So 5 is something which we are going to push onto the heap, and remember 2 and 3 has been removed from the heap. So 2 and 3 is gone from heap. So now the elements which we have is 5, 4 and 6. And again if we arrange it in the form of minimum heap, then what we are going to get is this heap. So 4, 5 and 6. Then let's take again the two minimum elements. So these are the two minimum elements. We are going to take it, and this will be equals to 4 plus 5, which is equals to 9. So now the heap contains element 9 and 6. Again let's arrange this heap 6 and 9. And now let's pop the two elements 6 and 9. We have popped it. So this is equals to 15, and once the heap contains one element, we are going to end our loop. And in order to find out the total cost will be given by 15 plus 9 plus 5, which is equals to 29, and that is what we are going to return. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let's say we want to find out the minimum cost, and an array is given to us. So what we are going to do is we are going to first convert this array into heap. So let's do that. So we are going to use the standard module heap queue, and we are going to heapify this, and the array will be converted to a heap. Once we have this, then let's have an answer, and initial value of answer equals to 0, and then let's iterate on heap while heap is not empty. So for that, len of array, and then let's pop the first two element of heap. So the first element is equals to heap q dot heap pop from array, and after popping the first element, it might be possible that the heap is empty. So if len of array equals to 0, then what we are going to do is we are going to simply break from this loop. Otherwise, let's pop the second element. So second element equals to heap q dot heap pop, and then let's compute the sum of first and second element. So first plus second, and let's update our answer. So answer equals to answer plus sum. And then towards the end, this sum is something which we are going to push it onto the heap. So let's push sum onto our heap. So heap q dot heap push and this sum. And in this way, we will be able to get our answer. And once we break from our loop, we just have to return answer. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So for the Python implementation, we converted the array into a heap and then answer equals to 0. Then we are iterating on array while length of array is not equals to 0. Then we are popping the first minimum element from the heap. Then we are checking if length of array equals to 0. If length of array equals to 0, then we are breaking from the loop. Otherwise, we are popping the second element and then s equals to first plus second and answer equals to answer plus s. And towards the end, we are pushing s onto the heap. And towards the end, we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ solution. So the C++ solution is also the same, folks. We have a heap over here. And then we are pushing all the elements of array into the heap. And then we are iterating on heap while heap is not empty. Then we are popping the first element of the heap. And if after popping the first element of the heap, if heap becomes empty, then we are breaking our loop. Otherwise, we will pop the second element of heap and then we will compute the sum, which is equals to first plus second. And then we will increase our answer. And towards the end, we will push that sum into our heap and then return answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.